Okay, so I would be introducing the new system that we are building right now, which is called BRANON. It's a kind of a development system for IoT based applications with programmable load controlling. That is basically here you can see that totally there are 8 number of loads that you can connect to the system, and as you can see over here, it's controlled by a triac, which is a solid state device, so you don't have any relays. And there are total number of 8 fixed loads and 2 variable loads. That is, here you have the 2 variable loads, and it is connected with the microcontroller using a optocoupler, which actually electrically isolates the device, or galvanic isolation is there. There are also the wiring diagrams which are given on the system, which help you to understand that how to connect the actual electrical load with this. Another feature is that there is a GSM modem connected. Although this is a very basic prototype which has been developed for college applications, that is purposefully why it is written in hand, but our industrial application or like professional application systems will be completely assembled on a printed and labeled platform. So this is the M95 modem, which is built on M95 module from Quectel. We will be soon shifting to M66, which is a better version, obviously, and the antenna is inbuilt, so you don't have to put any kind of SMA connectors. There's a wonderful 3.2-inch color LCD that you have connected over a 16-bit parallel bus with the microcontroller. Right now it's just running a picture clock, which is just a simple demo, but you can program it with a lot of applications you want. And it's crisp, and as you can see the photo out here, which is really nice. It's really beautiful. You can have any kind of graphical displays in the system for your development. Now let me move on to another special feature that is there with this board, that is a Bluetooth or Wi-Fi connectivity. That is, in case if you do not want to use the GSM modem, if your system is not supporting a GSM communication, or if you are not into a GSM communication, you can just simply omit the GSM module, and you can instead you can just connect your own Wi-Fi or Bluetooth communication module, or even a sub 1 GHz communication module. It is purposefully not, the SoC or the Wi-Fi SoC is not purposefully built on the main board, because you might want to connect a Wi-Fi processor, which is like say CC3100 or CC3220, which is a Wi-Fi SoC with integrated peripherals. So it's a kind of expansibility that you have, and it's communicating over the SPI bus. You can see these cables, these yellow cables. There are a total of 6 cables which is communicating over the SPI, and you can choose your own module. For example, you can also connect a Bluetooth, as it is connected over here. We have a BLE module that is based on the CC2541, which is a BLE chip from Texas Instruments. So you can connect your own BLE module, or if you want, you can also connect a CC13XX series, which is a sub 1 GHz module for developing Zigbee communications or mesh communications with this system. Another interesting feature with this is that you have a separate USB debugging port, which is connected to the central microcontroller, which is this one, and it is completely isolated from any other UART port. That is, it is not time multiplexed with anybody. So it's like there are separate receive transmit buffers for the USB, and you just communicate. And the CP2102 module doesn't have any conflict with Windows 10 or Linux systems, so it's a very platform stable product. And you can have all your logs. Suppose if you're running a real-time OS on your system, then you can have all the logs of your application at this port, and the port number is directly printed on the system. That is UCA3, that is UART channel of type A3, as we have in Texas Instruments system. That is UC module A, that is UC A3. So it's USCI A3 module that is connected to the USB port. You have an I2C expansion bus, as you can see over here. It takes some time to focus. You have an I2C expansion port, that is you have SDA, SCL, VCC, that is 3.3 volt VCC, and ground. So 4 pins are there for the I2C communication. So the better part is that you can expand the I2C port. Right now there is a R2C, RTC and an EEPROM connected. So if you want, you can connect your own port expanders and you can expand the number of GPIOs available on the board. There's one long communication or long distance communication, that is 485 module. So in case if you would like to communicate with another such module which is placed at some longer distance, you can communicate with this. Here you have a 2-wire SPI by wire JTAG port to connect it with the JTAG that is over here. We have a Texas Instruments MSP FET JTAG which is connected via these wires. So it's a 4-wire JTAG that is there on the board, but on the version 2 of the BRANON we'll be having a complete 7x2, that is 14-wire JTAG, that is the full 4-wire JTAG facility, which will give you better speed of access. And along with that, we have another thing which is very important to be noted, is that we have inside the system we have a SPI flash, which is 64 MB SPI flash, that I cannot show you out here because it's placed on the bottom side of the board. The SPI flash is intended to store the graphics that you need to display on this particular LCD, or maybe if you're running an RTOS, you need to interface you need to store some kind of data. So you have a 64 MB flash on board which you can use. And the SPI port is also available for connecting other devices, like you can choose to connect a micro SD card using SPI communication for even more storing of space. And finally, this is the super capacitor, this one, the black one. The super capacitor is a very good solution as compared to the battery, which is required for 1307 RTC, DS1307 RTC, because it needs to be changed from time to time. So here is an overview of the entire BRANON board that we are developing out here. More modern versions will be coming up, where I will show you the more advanced features. As of now, we have only BLE communication and IoT communication using the M95 modem. So here you go, this is the one. So for the next video, keep posted, and for any comments, you can have the comments written in the comment window. Thank you. Bye bye.